IPv6 address, which you see here, first of all, it is a 128-bit hexadecimal number. Two things you have to remember: 128-bit hexadecimal number. IPv4 was what? Totally numeric. One octet, that is from 0 to 255, one group or field can go value. IPv4 was decimal. That is why it was called as decimal dotted notation. But here you have 0 to 9 and A to F is also included. So all in all, you have 16 of them, 0 to F. F correspond to 50. So we have hexadecimal address being used, and since we have colon in between, IPv6 is a 128-bit IP address. Previously IPv4 was 32-bit addressing scheme. So 2 to the power 32 you can address. Here you can address, or you can give the address individually to all the system in the world. 128, 2 to the power 128, and that number is huge. Now new terminology was invented, 340 undecillion. So 3.403 into 10 to the power 38. Not only you take the Andromeda galaxy, you take all the whole solar system, and you have people there. You can assign the number and addresses to their machine. All right. Please recall, IPv4 was 32-bit address. It can only cater to 2 to the power 32-bit, that is 4.29 billion addresses. But IPv6, 340 undecillion. So we have here 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 sets, 8 field or 8 groups. How are they separated? They are separated by a colon. That is 2 dots vertically. This is the colon. So these are separated by colon. Each set, field or group, these are 16-bit. 16, how many are there? 8. 16 into 8 is what? 6 8s are 48, 8 4 carries, 8 1s are 8, 8 1s are 8, 12. 128-bit has come from there. Hexadecimal I already told you, and each hexadecimal character is representing 4 bits. For example, ODB8. This 0 or O, it will not be O, it will always be 0. We just have from A to F. So every DB8, all these are 4 bits. So that is why we have 4 of them, and 1 is 4 bits, so 4 4s are 16. So one group or one field or one set is 16-bit. Each hexadecimal 4-bit. This hexadecimal address, it contains not only the numbers, unlike the IPv4, it has alphabets also. A to F we are employing.